Hi everyone, welcome to Geek Coding Academy. Today we'll see Collection Framework chapter 6.12, that is Streams and the Collection Framework. So let's get started. So in our previous videos, we covered all of these topics under part A, and under part B, we covered most of the topics. In our very previous video, we talked about on immutable collections. So now we'll see what is streams and its use in the collection framework. So let's start. So guys, what do you mean by streams? So streams actually, it was introduced in Java 8. Streams provide a functional programming approach to handle sequence of elements. That means the data which we stored in our collection, um, okay, in our collection, the whatever data we have stored, that is for storing a data. We use a collection. For that stored data, we need to process the data, right? So for that, we can process it using a traditional approach, but using streams, we can efficiently process the data with a less number of coding, and also the performance will be much higher. So streams allow us to process collections of objects in a declarative manner, like filtering, mapping, reducing, etc. Like what does this? We'll see. First of all, I want to clear here, streams are not a data structures. They don't store any elements. They work on data source, okay, such as collections in our case, and process elements from the source, which is our collection. They'll process that, and possibly they will transform them into a different format and will return into a again a in a collection format. So let's see what is the key characteristics of streams. One is it is a declarative, means we need to express like what we want to achieve. Like means um, it's like in a declarative format we need to define, like suppose I have a data, what type of operation I need. I need to have a neatly declarative. I need to declare such that streams API will take care. And also it's a functional, means it uses a lambda expressions and IR add a function. That means it saves a lot of time. It saves a lot of coding lines. In a single line, we can able to define a function using a lambda expressions. They will know like only a parameter along with an arrow mark symbol and the body will be there. Method signature, return time and everything will we can able to avoid using a lambda expression. So that will also a lambda expression introduced in order to avoid much of a coding. Okay. And lazy evolution. That means like suppose I have a collection where I have some data I need to process. Suppose instead of streams, I go with a traditional way. I did something. Suppose I'm filtering, I can use some for loop and some if conditions to filter out some data. So everything will be, if I do something like a for loop and if, everything will be act immediately. But if I use streams, it will not act immediately. I can only declare it unless until I call the terminal operator. It will not process that data. This is lazy. Means operations are performed only when necessary. That is, in terminal operation trigger the streams processing. And parallelizable. That means we can split this work, the whatever we need to process the data into multiple threads for better performance using parallel stream. There is a parallel stream concept under stream. That means like suppose we want to segregate the data which is stored in our collection, we could have used the two threads and it will split the work, which increases efficiency. So let's see what is stream pipeline is. The source for this pipeline, this stream is a data source like collection or an array. Okay. So there are two type of operations will be there in these streams. One is intermediate operation and another one is a terminal operations. So these intermediate operations are lazy operations. Until and unless a terminal operations are being called, these intermediate operations will not execute. Okay. What is this intermediate operations? Like operation that transform streams into a another stream. Means suppose like I have a collection of data, I just transform them into a stream. Stream means a data by data. Each like it's just like a for loop. You can think of like that. And I did some intermediate operations like filter it out. I just need only some type of data on specific condition. I'm just filtering out from my entire data into a particular data which I needed. That is what it transforms streams into an other streams, like other data, other form of stream. And these operations are lazy and it does not execute until a terminal operator is invoked. Like what are intermediate operations? We'll see. Filter, as the name indicates, a filter, it's filter elements based on some condition. Map, that means it transforms each element. Suppose like I just want the element stored in my collection to be in uppercase. I could have used this map and make it as an uppercase. So it will transform each element into whatever type we need. And sorted, it will sort the elements. So these are all the intermediate operations. What is terminal operations? Means the operation that produce a result. So unless and until we calling a terminal operation, this intermediate operation will not execute. That's the reason we call it as a lazy evaluation. So operation that produce a result such as collecting elements or calculating aggregated values. So what are terminal operations are collect. As the name indicates, it collect the stream, whatever transformed stream we got, it collect and it will return back in the form of a collection. Yeah. And also for each. Let's see what is for each. For each means it will applies an action on each element. It will iterate each element. The other method is reduce, which combines element of stream into a single result. Okay. Let's see an example so that you will be more clear. So how we can able to work with streams is, let's see an example. First, we need to use in our example, you can see here, I'm just using this utility class arrays dot as list to creating an array list. So you can use like this, or you can create a traditional way of creating an array list. Like you can create a new of array list, then using an add operator, you can add values also. Here I just created using in a utility classes arrays dot as list and I passed all the values. So what it will do is it will uh, provide me an array list which is of type list of string. Okay. So these names, you can see here names dot stream. If you type dot stream, it will, this name is the my collection of data. It will be passed to stream pipeline as a source. After that, I can do two type of operation. One is intermediate operations and second one is a terminate operation. This filter and map is the intermediate operation. So after that dot filter, this method, for this method, I need to call the parameter like name. This is just like a individual element it refers. Dot filter name means like it will gives one by one where name dot starts with J. I'm filtering out the entire data into and allowing only data which names are starts with J, and dot map. I'm just using a one more intermediate operation here dot map where this string I'm making into an uppercase. Okay. I'm just formatting what all data which name starts with J into an uppercase. Okay. After that dot collect, that is a terminate operator. So the dot collect, what it will do is what are the up to here we have a transformed stream, right? Like we have one more data source we passed, and after some operation we have a transformed stream. That stream will collect it into a list. So whatever list we collected will be having only name starts with J, and that too they are mapped to, means they are converted to uppercase. Okay. So let's see what all types of streams we have. We have a sequential stream. That means it process element in a single thread. That means if you pass a source collection to it, like only one thread will act on this. That whatever we example we saw, that is same. That name start stream, we are calling a stream API dot filter. That means one intermediary operation we are calling. After that dot collect, the whatever operated we are collecting that is terminate operators. Similarly, we have another type of streams that is parallel stream. Means it divides the source into multiple substreams and process them parallelly. Okay. So it will be efficient. More than one thread will be acting on this. That's the reason it's a parallel stream. The efficiency will be more. Names dot, to call this, we need to use names dot parallel stream. Instead of stream, we can call as a parallel stream dot filter and dot collect. We can use same terminate intermediary operator and terminate functions we can call. Let's see what is intermediate operations available in streams. All one is filter, which excludes elements based on some specific condition. Map, which transform each element. Distinct means it will remove all the duplicates. And sorted, it will sort the elements based on natural order. If you provide a custom comparator, it will sort based on that. Limit, suppose in a list I want some filtered and I need some limit number of elements, we can able to use limit. Skip, I need to skip some of the first few elements, I could have used this skip. These are all intermediate operations. So after calling a stream or a parallel stream, we need to call these intermediate operation based on our specific needs. And these operation will not execute immediately until a terminate operator, terminate functions are called. So let's see what are terminate functions, terminal operations. One is collect, that the mostly we use this because we need to collect the transformed data, right? So this convert stream back to collection, the transformed data back to collection format, and we can capture it. For each, this one by one, like it perform an action for each element, reduce, combine element in a single result, count, it will count the number of elements after whatever intermediate operations we did on the data. After that, what number of elements are left out, it will count. Any match, all match, none match, these are all checking conditions on elements. So let's see streams and collection interplay. The collection framework and streams are deeply interconnected. After Java 8, we can easily create a stream from collection and perform operation on it. Suppose like in our previous example, we see I applied for array list. Similarly way, I have created one more list, which is of type list of integer as a numbers. So I'm calling in a stream, numbers dot stream dot map. This is an intermediate operation where individual element n, I'm taking as in one variable, temporary variable n, which will hold individual element by element n. This is a lambda expression we are using, this functional programming lambda expression. That means n, where the body will be n into n. That means whatever data I get one by one, I'm multiplying it with itself. That means square I'm doing. Dot collect collector dot to list. Okay, here what I'm doing is numbers dot stream generates a stream from the list, stream of data from the list, where map n arrow n into n squares each number, and dot collect, where collector dot to list converts the result back to into a list. Okay. So what's the key differences between collection and stream? So many people confuse us. Streams means they think of maybe it's a one of the type of collection, but here clearly we have to see collection is totally different. Collection is used to store data and manage data, whereas stream used to process data. Without stream also we can able to do some operation and collection. That's what we are doing before Java 8. But after Java 8, streams were introduced in order to make developer life easy and want to do operations which were performance will be much higher, and also in a single line we can able to write a code. Okay, streams used to process data using a functional programming approach. Okay, collections are eager, like any operation you applied on a collection that will be done on spot itself, but streams will wait until a terminator operations are called, like meaning operations are performed that are called in collection, whereas in streams are lazy and only execute operation when required. So guys, this all about streams. This is a small concept, but it's very powerful in if you are working with collection and collection concepts, because after Java 8, this collection framework turned into a different route. Using streams, we could have write a more complex code into a much smaller line of code, lines only, so that it will be more readability. And also streams, using streams, we could have easily transform our data of the data which we stored in our collections. And this is what end of our collection framework. In our next video, I'll talk about what are the best practices and how to pick a right collection classes with a basic what a requirement, like a best requirement to the best collection, what it is. We'll discuss this briefly and we'll wind up this collection framework. And our next video will start on Java IO, that is input and output operations in Java. So I hope you guys enjoy this video. If you like this video, please share this video to your friends and colleagues. And if you really learned a few things from this video, please subscribe to our channel. I'll meet you guys in my next lecture. Till then, keep watching, keep learning. Thank you. Bye.